Hey, grade 10. So we are now entering the last unit of the last lesson of unit 7. So like I said, as I promised, it's a very short unit. So there's really only two lessons, big lessons that we went through. Like I said, it's kind of subcategorized into 4 topics, but really we were able to kind of squeeze them into 2 lessons here. So what we're talking about now is arithmetic and geometric series, and let's get started. So first question, if I asked you to find the sum of numbers 1 to 100, how would you actually do that? So obviously one way is to grab a calculator or do mental math, figure out what 1 plus 100 is. Add all the numbers from 1 to 100, and that would take a while to add 1 plus 2 plus 3 plus 4 all the way up to 100. But maybe there's a better way to do this. So an easier way to do this is to actually write out the numbers 1 to 100 in 2 separate lists. So write the first half of them in the first line and write the second half of them in the second line. And what we're going to do is we're going to purposely put the first line in ascending order. So it's going to be getting bigger and bigger. And in the second line, it's going to be in the descending order, which means they get smaller and smaller. So what we notice is that when we do this, we actually pair up the smallest number from 1 to 100 with the largest number from 1 to 100. We pair up the second smallest number from 1 to 100 with the second biggest number from 1 to 100, and so on and so forth. And when we add them up, when we add up the two halves, we'll actually notice that when we add each of these numbers that are over top of each other, we actually always end up getting one whole sum, right? Which is common to all of them. It's 101. So what we end up with is 101 plus 101 plus 101, and that's actually added a total of 50 times. And it's 50 times because we split the numbers into two halves. So half of 100 is 50. So we can see here that the total sum is 5,050. This method was created by Carl Gauss, who's a very famous mathematician. And what's crazy is he was really young when he did this. Apparently, the story goes that the teacher wanted to keep the students occupied, and they gave them a task that the teacher gave a task that thought would take a long time, but actually Gauss was able to figure this out quite quickly. So from this, bit of brainstorming or problem solving that Gauss was interested in, we actually developed a whole set of math and formulas from this. So it's kind of interesting to look at this. So what we're going to be looking at in this case is the sum of different sequences. So what if I gave you a sum of numbers from 1 to n, right? So in the last example, it was obviously easier because I was looking at numbers 1 to n. Can we generalize this? Well, we could. So to generalize this, what we say is, let's just list off all the numbers from 1 to n. So if I wanted to add all the numbers 1 all the way up to n, that means I'm going to be adding 1 plus 2 plus 3 plus 4 all the way up to n plus n minus 1 plus n minus 2 plus n minus 3 plus n minus 2 plus n minus 1 plus n. And if you're wondering what the n minus 3 means, it simply means 3 numbers less than the last number we're looking at. N minus 2 means 2 numbers less than the last number we're looking at in the sequence. And n minus 1 is simply 1 number before the last term there. So what we notice is that we can once again list off the numbers in ascending order in the first row. And in the second row, we're going to list them in descending order, which means from biggest to smallest. And similar to what we did in the last example, we can actually add up the numbers, or in this case, the variables over top of each other. So we know that 1 plus n gives us n plus 1. 2 plus n minus 1 gives us 2 plus n minus 1, which is n plus 1. 3 plus n minus 2 actually ends up giving us n plus 1. And 4 plus n minus 3 gives us n plus 1. And I think you kind of see the pattern here. We have n plus 1 repeated over and over again as a sum. And how many do we have there? We have a total of n. So what we realize is that there's a shortcut to finding this answer here. Because I have, now keep in mind that what I did here is I added the 2 rows of numbers, but really that ended up giving me what 2s is equal to. Now the question didn't ask what is 2s equal to. The question really asks, what is one of these rows equal to? That's all we're really interested in, right? So we notice that we're simply adding the same row of numbers twice. And when you add a number twice, then you can just write it as 2 times that number. So what we end up finding is that this expression that we have underneath here, we can actually rewrite that as n, we can rewrite that as n times n plus 1. We're basically adding n plus 1 a total of n times. So we have n of those products. And because that's equal to 2s, I can figure out what s is simply by dividing by 2 on both sides, and then I can get the sum that I'm interested in. So I notice that the sum of all these numbers of any number, any sequence of numbers that increases from 1 to n, and it's increasing by 1 the whole entire time, we can actually take n and multiply by n plus 1 and divide by 2. And again, n simply represents whatever number we're trying to add up to, from 1 all the way up to that final number. So for example, if I wanted to find the sum of numbers 1 to, I don't know, I'm making this up, 80, we can use this formula, and we can simply write 80 times 80 plus 1. So n simply represents the total number of numbers that we have there, and they're all increasing by 1. And then I divide by 2, and so I take 80 times 81, divide by 2, and that gives me my sum. Again, I'm not going to put this on a test. I promise you it's not on a test or a quiz. It may be something that might come up in the culminating task. We're not 100% sure yet. We're still in the works of creating it. This could be something that could potentially come up in the culminating task, but it will definitely not be on your quiz today. So do not stress about this, okay? This is more out of interest. I think it's just interesting for you to kind of see where these concepts of series and finding the sum of different sequences comes from. So I kind of already revealed a word that's new to you, series, and I'll talk a little bit more about this. Just letting you know that there is an interesting video that you can watch if you want to know more detail about the proof of this, but I will not go over the proof. I'll just kind of leave that to you if you want to discover more about that. So what is a series? So in the last question, we actually saw an example of a series. It's basically the sum of terms of a sequence. So there's different types of sums that we could have. So the first type of sum that we could have is a partial sum, which is basically s at n. That's the sum of the first n terms of a sequence. So this is really important because there's going to be some series that are infinite, which means that there's actually no end to them. So you won't necessarily always be able to find the sum of these infinite series. When you take math in university, you're going to learn about infinite series and the sum of infinite series. That's really interesting, actually. It's really cool. But for now, we're going to focus a lot on partial sums because a lot of our series are going to be infinite themselves. In later courses, just so you know, instead of actually finding the sum of values, we actually use a symbol. This is really, really common. We're going to start using the sigma notation, but for now, you're probably just going to see the numbers added together. So it'll be pretty clear when you're looking at a series. So what's really important for you to understand is that a series basically stems from a sequence. And I think this is where people get confused because they kind of think that a series is a totally separate beast on its own. It's actually related to a sequence. It's essentially the sum of terms in a sequence. So you're still looking at a sequence, except that you're adding the terms. That's the only difference. Before we weren't adding the terms. In a sequence, you just list them off. In a series, you add them, okay? So in a series, you add terms or term values. In a sequence, you simply list term values, right? So that's kind of the difference between them. So as an example, we know that the sequence 2, 4, 6, 8, that's an arithmetic sequence where the difference is 2. So we add 2 each time. But we notice that if we were to add them up, this would automatically become a series. And the sum of this series would be 20. So if I only had 4 of them in this sequence here, then the sum is pretty easy. It's just 20. However, I could look up partial sums. What if I'm only interested in adding the first 2 terms? So if I'm only interested in adding the first 2 terms, I can just add the first 2 there and I get, sorry, I can't write underneath here. It's going to be supposed to be an equal sign, 6. Sorry, s at 2. If I wanted to look at a partial difference for 3, so s at 3, I would take 2 plus 4 plus 6, which is 12. And if I wanted to look at a partial difference of 4, well, that wouldn't really be, that would basically be the whole entire sequence there. If I wanted to add all the terms in the sequence there, I would simply just find s at 4, which we already said is 20. So that would be the sum of the whole series there. So I hope that kind of makes sense. So we are allowed to find partial sums as well within our series. So how do we find the sum of arithmetic series? So the first example kind of illustrates a strategy we can use to find the sum of different numbers from 1 to 100. But the problem with this is, in the last example we did, we were looking at adding numbers 1 to 100 or 1 to n, but they were all increasing by 1, so they were all consecutive. So if it's not consecutive, then there's actually a general formula for this. There's two formulas, and actually we'll talk about them. The first formula you could use is to simply take n and you divide by 2, and then you multiply by 2a plus n minus 1 times d. Or a different way to rewrite this, if you prefer, some people prefer this, since you're multiplying by a fraction, you can just divide by 2, right? We simply put the 2 in the denominator there, and we take n times 2a plus n minus 1 times d, and then we divide all this by 2. So what do all these variables mean, or what do all these letters mean? So I'll kind of explain this step by step. The sum, S at n, is basically the sum of the first n terms. Again, we never, ever, ever assume, it's the second term to the fifth term or something like that, right? That's a whole different can of worms. If you ever had a question like that, you could do that, but you would need more than just a formula. You'd have to kind of reason it out differently. This formula automatically gives you the sum of the first n terms, okay? So just remember that, first n terms, and n representing, whatever partial sum you want. So if it's S of 5, it's the first, that would be the sum of the first 5 terms. I'm just giving you some examples so you kind of see how this works. Okay, A is the initial term, D is the common difference, just like we've seen before, so not too different, and N is simply the index of the term. So the first one, the second one, third one, whatever it might be, okay? And in our case, N would simply represent the number of terms that we have in our partial sum. So an alternative formula that you could use is S at n is equal to n times t1, which is the first term, plus the last term divided by 2. And actually, this is really similar to what you saw in the example where we were actually looking at the sum of 1 to 100. So this was actually a very similar idea. To find S at 100, you would simply take 100 plus the first term, which is 1, plus the last term, which is 100, and you divide by 2. And this ends up giving you 100 times 101 divided by 2. So this formula is more familiar to you based on what we just did. So it's a different formula we can use. And again, same idea. T1 is the initial term. Tn is the last term in the series, okay? Or in your partial sums, whatever you might be looking at. So at times, it really depends. There's two different formulas, and this is where people get confused because they're like, which one do I use? It just depends on the situation. Sometimes it's better to use this one. Sometimes it's better to use the other one that we just looked at. It really just depends. Sometimes it's actually the first and the last term are given to you. And if that's the case, I would use this formula. But if that's not the case and you're actually given the common difference in the first term, I would stick with the first formula that I showed you here, which is this one right here. So it's totally your preference of which one you use. For both formulas, you do need to know what n is. So that doesn't change at all for either one. You need to know what n is, and you definitely need to know what the first term is. So for this formula, the last one we just went over, this one on this page, we need to know the last term. For the first formula, we don't need to know the last term, but we definitely need to know how many terms are actually in the series. There is a proof for both of these formulas, but just for timing's sake, I'm not going to include that. I'm not going to discuss it, but you are more than welcome to read up on it. It's on page 449, and I definitely recommend that you do that. Like I said, guys, we're trying our best to just focus on the main material. I would love to have more time to go over this, but I will leave it for you to just research on your own. So let's look at this arithmetic series. So we have 3 plus 9 plus 15 plus 21, and so on. So let's find out what t at 50 is, and then let's figure out what s at 50 is. So t at 50, again, just a reminder, t at 50 is basically asking you for the 50th term. So this is not asking you for a sum. It's not asking you to add anything. It's just asking you for the 50th term. So in order for me to know what the 50th term is, I need to know what the general term is. So this actually goes back to what we just learned about. I need to find out what the general term is, and I do that by identifying the first term, which is 3, and the common difference, which is 6. So that means that my general term is going to be t at n is 3 plus 6 times n minus 1. So again, I go back here, I notice that I am adding 6 each time. So that's my common difference. And my first term is 3. So that's where I'm getting the D from, and the A value is simply 3. So that means the general term is T at n is equal to 3 plus 6 times n minus 1. And then if you want to find the 50th term, this is pretty easy. You simply let n equal 50. This is just like a function. I simply sub in 50 into n, and this gives me 3 plus 6 times 50 minus 1. Again, you multiply first. So brackets first, then you multiply. 50 times 1, 50 minus 1 is 49. And then I end up with t at 50. So I'll do the math here. 6 times 49, and then I multiply first. So 6 times 49, then you add the 3, you end up with 297. So this is going to be my sum of the first 50 terms, right? This is the sum of the first 50 terms there. Now, for the second, sorry, not the sum of the first 50 terms, sorry, I'm going a little ahead. This is simply the 50th term. Sorry, that's what I meant to say. This is just the 50th term. So we haven't actually found the sum of any of the terms yet. So if we want to find S of 50, what S of 50 is really asking you for is the sum of the first 50 terms. That's really what it's asking you for. So if I can go back to this example and imagine that this went on for a total of 50 times, right? Like we would have 50 terms, and we know the 50th term, by the way, what did we say it was? I totally forget. 297. So the question is really just, what is the sum of all these numbers added up together? So if I were to add all of them up, what would the sum be? So for me to do this, I need to use the formula. And the formula basically tells me that I need to identify what the n is. In this case, the n is 50, the d value is 6, and the a value is 3. It's actually pretty easy. So then I go to my formula. So if I want to find out what S of 50 is, I am simply going to replace the n with 50. I replace the a with 3. And again, it's just a matter of being careful with the formula. 50 minus 1, so n minus 1 is 50 minus 1 times the difference, and then I divide all this by 2. So this ends up giving me S of 50 is equal to 50 times 2 times 3, which is 6. 50 minus 1 is 49. 49 is multiplied by 6. And then this ends up giving me, and then I divide by 6 there. So now I take 6 plus 49 times 6. That ends up giving me S of 50, which is 50 plus, and again, 49 times 6. Let's just figure out what that is. So 49 times 6. I add 6, I end up with 300. And I'm trying to write underneath, so I apologize for that. I divide by 2, so take 50, take 300, multiply by 50, and then divide by 2. This ends up giving me 7,500. And again, I showed every little step here. You don't have to show every little step. You can just give me the final answer there. That's fine. As long as you show me what you subbed in for the A, D, and N value, right? That's really important. So you don't have to show me all these intermediate steps as long as you show me the substitution. And again, it's for your own sake, right? Because you definitely don't want to lose marks for something like that. However, if it is multiple choice, like I said, for the quiz itself, because it is correct or not, and I don't actually want you to show the work, just give me the answer. But this is more for your culminating or for any other task that you have other than the auto-graded questions. So could we use the alternative formula? Absolutely, right? So the alternative formula says take the first term, which is T1, which was 3, and take the last term, which is in the partial sum, which is the T50, which is the 50th term. And it says simply add them up. So add the first term and the last term, T1 and T50, 3 plus 297 multiplied by n, because that's what it told me to do in the formula. So the formula says S at n is equal to n times n T1 plus Tn, and then divide by 2. So we simply replace the n with 50, multiply 50 by 300, and then divide by 2. You end up getting the exact same answer. So regardless of how you solve, which formula you use, you get the same answer either way. Let's look at a different question. What if you are asked to find the sum of an arithmetic series, but you don't know how many terms you have? So these questions get a little bit tricky because you have kind of a preliminary step before you actually solve it. So if I'm asked to find the sum of this arithmetic series that starts with 5, 8, 11 plus ... to all the way up to 182, what do I have to do here? Well, I'm going to have to first work backwards to figure out how many terms I actually have. That's the first step. How many terms do I have here? Well, to find out how many terms I have, I am going to have to use the formula that we used in the last lesson. We learned that the number of terms you have is, if for an arithmetic series, by the way, this doesn't work for geometric series, is simply going to be Tn. So whatever the last term is, right? That's simply what this is saying. It's the last term minus the first term. And when we just divide by the common difference. And then we simply add 1 at the end. And again, we add 1 to make up for the fact that we start adding the common difference. In this case, the common difference is 3. We add the common difference after the first term, which is 5. So in our case, we're going to basically work backwards with this when we say, well, 182 minus 5 is 177. And we know, once again, that the common difference is 3. And then remember, we need to add the 1 to the quotient because we talked about this. You start adding the common difference after the first term. So that means that the number of terms is simply going to be 177, which is 182 minus 5, divided by 3, and then you add 1. So 177 divided by 3, and then you add 1, you end up getting 60, and you can verify yourself. So now I know what n is. I know how many terms I have. I know what the common difference is, and I know what the a value is. So now I can plug it into my formula, and I'll let you kind of do the formula yourself. It's not too hard. You simply take 60 times 2 times 2 times the a value plus n, which is 60 minus 1 times the common difference, and then you divide all this by 2. So again, going step by step here, we end up getting 2 times 5, which is 10, and I'm showing less and less steps here because I think that most of you are okay with this. If you still need some help, I can definitely show you step by step here. I am simply taking 2 times 5, which is 10. 60 times minus 1 is 59, so 59 multiplied by 3. I'm finding out what 59 times 3 is. So 59 times 3, and I'm going to verify all these questions are correct. All the answers are correct. That gives you 187, and then we end up with 60 times 187. We divide all this by 2, which is exactly what I have here. I end up getting a final answer of 5,610. And that is the sum of the first 60 terms. So sum of first 60 terms. And again, this question was a little bit different because they didn't say, find the sum of the first 60 terms. We had to figure out how many terms we had to start with, right? And again, to figure that out, we had to kind of use our reasoning, right? And this is where we kind of used our logic step, right? We basically noticed that the difference between the first term 5 and 182 was 177. And because the common difference is 3, we simply divide by 3 to find out how many terms are between it. But remember, we had to add 1 because we start adding the common difference after the first term. And again, if you're still a little confused by this, I would definitely recommend going over lesson 1. I kind of go over this in a bit more detail. I didn't talk about it as much here because I kind of assumed that you understood it the first time there. So let's do another example where we have to find the initial term and the common difference. So if we are asked to find the sum of the first 20 terms of an arithmetic series where the 7th term is 43 and the 13th term is 109, what do we do? Well, if we're told that the 7th term is 43, then we might as well write it out in terms of in sequence notation. So we know that t at 7 is 43, and we know that t at 13 is 109. This is what we know so far. So what that means, kind of like what we saw before, we can find out what the common difference is, but to find the common difference, you are essentially you're almost using your knowledge of slope in grade 9. So if you recall that in grade 9, to find the slope was essentially the change in y over the change in x, right? You probably remember that. Hopefully you remember that, right? That was slope, change in y over change in x. It's the same kind of idea here. We're essentially just finding out, and again, I'm going to erase this because it looks a little messy. We're essentially just trying to figure out what the change in the term values are, and then we're dividing by the change in the actual term numbers are, right? So we know that the term values have changed by a total of 100, so 43 to 109. How much of a difference is that? That is a total of 64. Oh, sorry, not 64. Sorry, guys, this is 66. And then, of course, the difference in the term numbers there is a total of 13 minus 7, which is 6. So we know that the term values have increased by 66, but the term numbers have increased by 6. So that would mean that the common difference would be 11. Again, lots of different ways you can reason through that. You don't have to use a formula like this, but I feel like this is probably what I think is the easiest way to look at it, right? You almost want to compare this to slope, and slope, which is the change in y over change in x that you did in grade 9. So now that I know what the common difference is, because you're actually given the seventh term, you wouldn't always be able to do this, but because you're given the seventh term, you could definitely work backwards to figure out what the first term is. So again, I've kind of explained that there are multiple ways to do these questions, right? So t at 13, we were told is 109. T at 7 is 43. You could work your way backwards, especially because you're just subtracting. You could work your way backwards to figure out what the first term is, which basically means that you're going to be subtracting the common difference. So instead of adding, you're going to be subtracting the common difference. You do the opposite to find out what T1 is. So we're going to be subtracting 11 a total of how many times? Well, again, if we want to go back to the first term, we actually don't subtract it 7 times. You would think you subtract 11 7 times, but you subtract 11 a total of 6 times. And again, it's a total of 6 times because, again, to go to T6, you subtract 11 once. To go to T5, you subtract 11 twice. To get to T4, you subtract 11 3 times. To get to T3, you subtract 11 4 times. To get to T2, you subtract 11 5 times. And to get to T1, you subtract 11 6 times. So you actually subtract one less than the number terms, right? So you would think and again, this is what throws people off. You would think it's 7 times, but remember, we're going to T1. We're not going to T0, right? So that means that you're subtracting the common difference 11 times. So we take away the common difference, which is 11, 6 times, which means that we're really just subtracting off 11 times 6, right? Because really repeated addition is multiplication. So we take 43 minus 11 times 6, which gives us negative 23. There is a different way to do this, and again, it just depends on what you prefer. This is again, what I kind of showed there. I would call this more not common sense, but more kind of reasoning through it or drawing a picture to help illustrate this. I know some of you actually might prefer algebraic steps, and if that's the case, and I'm kind of more in that camp anyways, I kind of prefer more algebraic steps. You can definitely do this. So you can start off and say, all right, well, the general term I know is going to be t at n is equal to a plus d times n minus 1. I know my common difference is 11. So I have a common difference of 11. And what I can do is I can say, well, I know that my seventh term is 43. So that means that t at 7 is equal to a plus 11 times 7 minus 1. And I can just figure out what a is based on this. Well, do I know what T7 is? Absolutely. I know that T7, we're told, is 43. So that means that 43 is equal to a plus 11 times 6, because 7 minus 1 is 6. And then to figure out what a is, I simply, I'm just solving an equation. So 43 is equal to a plus 66. And of course, I take away 66 on both sides. And notice that this gives me the exact same answer that I have up here, which is negative 23. So that's a different way that I could approach this problem. I didn't have to reason through this. I also could have used algebraic steps as well. I could have used the common term and simply sub in what I know and work backwards to solve for what I don't know, which is a. So lots of different ways I could solve for that. Either way, I hope you were able, again, as long as you're able to reason it in some way, then you're good. So now that I know what my a value is and what my n value is and what my d value is, I simply sub them all into my equations. So I know that a is negative 23, d is 11, n is 20. So that means I have in my formula n times 2 times, and again, going step by step, this is your n, 2 times a, which is negative 23. Then I have n minus 1 multiplied by d, which is 11, and then I divide all this by 2. So then going step by step, 2 times negative 23 is negative 43. So I'm going to show the steps here. So I have 20 times negative 46, sorry. So 2 times negative 23 is negative 46. And then I have 20 minus 1 is 19. And then I multiply 19 by 11. Sorry, let me grab my calculator here. So 19 multiplied by 11, that gives me 209. And again, I'm adding it. So to add 209 and I divide by 2. So my next step, I find out what negative 46 is. I subtract 46 from 209. Think of it that way. Then I have 20 times 163. I divide this all by 2. I end up getting 1,630. So that is my final answer there. Again, just verify that you have this correct as well. So that brings us to our next topic, geometric series. So we are done looking at arithmetic series. Now let's look at geometric series, the sum of geometric sequences. So notice that going back to our previous examples here, just want to show you one quick thing here. If you'll notice, I was calling it the sum of arithmetic sequences, and then I just switched over to the formula for the arithmetic series, right? So again, it's because our series is really stemming from the sequence, right? I hope you kind of understand that this is not a different species of its own. The series are basically just the sum of the terms in a sequence, right? So in the sum, to find the sum of a geometric series, a sequence, again, we notice that a geometric sequence basically has a common ratio, so a multiplicative factor that it's increasing of the geometric sequence. Again, the formula is not very pretty. And I apologize for it. I wish it looked prettier, but it doesn't. But the one good thing about this formula is that when you actually get to financial math, we see a formula that is extremely similar to this. So I almost feel like it helps to actually see this twice. So you're going to see that the first time now. And the second time you see it, I'm hoping in Unit 8, when you look at the formula again for annuities, we'll talk about what that is. I'm hoping it makes more sense and looks more to memorize them. You always have them in your notes. As I said already, your tests are open book. Your culminating task will also be open books. So there's really no need for you to memorize these formulas. You should write it down so you know exactly where it is, and make sure you write it down correctly, because you don't want them to be wrong, because then all your answers are wrong. But these are basically the two different formulas we could possibly use. Again, notice that the first one relies on the A, basically the number of terms. And the second one just relies on knowing what the first term is. And keep in mind, it's not the last term, but it's the term after the last term. So again, all these variables should be familiar to you. A, again, is the initial term, or sometimes instead of initial term, use T1. Our common ratios are the n is the index number of terms, the number of the term that we're looking for. And n plus 1 is simply t at n plus 1 is simply the n plus 1 term. So if I have t at n, that's my last term there. T at n plus 1 is just the term that comes right after. That's all it is. And again, there's proofs for these formulas, and you're welcome to look at them, but you do not need to know them for your tests or your quiz. So let's figure out what S at 8 is for this geometric sequence. So I'm not always, and actually I should clarify series. Apologize for that. Let me just make that change, because I will definitely forget if I don't make that change. So in this case, we just want to find out what the sum is of this geometric series. So it's 3 plus 6 plus 12, and so on and so forth. So what we're going to do in this case is, and I'm just going to make the change to this one as well. This is the one that you're going to be looking at anyways. So one thing that you need to remember for your quiz, I'm not going to always specify whether it's geometric or arithmetic. So you do need to know that as well. But I'm hoping that you'll become more familiar with that the more you see it. Okay, so I'm going to go back to the last example here. So if I want to figure out what the sum of this geometric series is, so we first notice we have to first identify what is the common ratio. So I hope you can see here the common ratio is simply 2, because I'm multiplying by 2 each time. And what we're doing now is we're then identifying what the initial term is, which is 3. And we know that it's asking us for S at 8, which is basically the sum of the first 8 terms. So we have n is equal to 8. So what I'm going to do now is I'm simply going to sub in all my key information here into the formula. So I have A is equal to 3, N is equal to 8, and R is equal to 2. So I sub it into my formula there. So not too hard here. Really, what I'm trying to do is just find S at 8, which is the sum of the first 8 terms. That's really what I'm doing there. Okay, find the sum of the first 8 terms. So I take 3 and I multiply by 2 to the power of 8, and I subtract 1, and then I divide by 2 minus 1. Again, grab a calculator. 2 to the power of 8 is going to give us, sorry, I apologize. It's going to give us 256. And then I take 256 minus 1. I divide by 1, so this gives me 3 times 255. I divide this by 1, and this ends up giving us 765 as our total sum there. And again, you can go through the steps there and make sure you got the same answer as me. How do you find the number of terms? So let's do an example that is a little bit different. So in this question, again, it's kind of similar to what we saw before with the arithmetic series. Again, a lot of these questions are going to be really similar. So the good thing about it, like I said, is you're going to kind of follow very similar strategies as before. They're not, that's why I kind of joined them into 2 lessons, because really, even though arithmetic and geometric series are different, we use very similar strategies for them. So we look at this and say, well, first of all, I can identify it's geometric, because if you ignore the sum there, it's really just a sequence, but the only difference is I'm adding it. And I notice that I am multiplying by 3 each time. Now, the question here is, I know what I'm multiplying by, but I still don't know what I know what my first term is, and I know what my last term is, and I know what my common ratio is. But, and again, the common ratio is simply found by dividing terms. So I take 6 divided by 12, 18 divided by 6, you can tell, 6 divided by 2 and 18 divided by 6 gives you 3 for both cases. So I can see here that my common ratio is 3, and then I know my initial term is 2. Now, the problem with this is that I don't know how many terms I actually have. So to figure out how many terms I have, what I'm going to do is I'm going to at least start setting up my general term. So I know that my last term there is 4,374. Sorry, just taking a water break there. So I know that my last term is 4,374. So what I'm going to do is I'm simply going to sub that into my formula. So I make 4,374 equal to t at n. So this ends up giving me 4,374 is equal to 2 times 3 to the power of n minus 1. And again, all I'm doing is simply replacing the term value with t at n in the formula, the general term. I'm going to divide by 2 on both sides. So when I divide by 2 on both sides, I end up getting 2,187 is equal to 3 to the power of n minus 1. So one really common mistake a lot of people make, and I know why this happens, it's just your eyes that are tricking you. You're very, very tempted to want to multiply the 2 times 3, right? Don't do that, please, okay? We're not multiplying 2 times 3. You're going to have 3 to the power of n minus 1 on its own. Now, this is still not that easy to solve, but you can solve it using guess and check, or just using your knowledge of powers. So really what we're trying to figure out is 3 to the power of what gives me 2,187. Now you could try different exponents and try your best to come up to a close answer there. There is actually going to be one whole number. And again, the great thing about this is that for all these examples, the n is always going to be a whole number, right? And that's why they're called discrete functions. They're not going to be decimals at all, right? We can take 3 and we can try different numbers. We know 3 to the power of 5 is 243. That's too far, right? 3 to the power of 6 is 729. And then we have 3 to the power of 7, which is 2,187. So this is actually the answer I'm looking for. So I know that 3 to the power of 7 is 2,187. So if I know that this exponent right here is equal to 7, this is actually similar to what we did in unit 4, because the powers are equal to each other. So we notice that we get the same answer there. That means that, and they have the same base, that means that the exponents are equal. That means that n minus 1 is equal to 7. And if n minus 1 is equal to 7, this is just a little bit of algebra you have to use here. You add 1 on both sides, and then you end up with 8. That means that n is equal to 8. So that means that there are 8 terms. So now that you know that there are 8 terms, by the way, there's not always going to be 8 terms. It just happens to be this way. Now that you know that there's 8 terms, you know the initial value of the geometric series is 2, and you know that that's a, and then you know the common ratio is 3, so you simply sub it into your formula. And again, I'm going to let you just do the formula stuff on your own because that's relatively easy, okay? A different alternative formula you could use is you could figure out what t at n plus 1 is. And again, t at n plus 1 is simply the term that comes after the last term. So if we go back to the question here, right after by multiplying by 3, and when you do that, you end up with 13,122. So now that I know what my last term is, I can subtract off my first term, which is 2, and I simply divide by r minus 1. So this ends up giving me, so I go back to my formula. And again, if you're confused by this, just go back to your formula. You don't have to have it memorized. So we know that we take the t at n plus 1 term, so the term after the last term, we subtract the first term and we divide by r minus 1. So going back to our question here, just showing you a different way you can solve this. You take the term after the last term, 13,122, you subtract off the 2 because that's the initial term, a, and then you divide by 3 minus 1, which is 2. And then that ends up giving you 13,120 divided by 2, which gives you 6,560, which is the exact same answer that we had before. Series. But again, what made this question hard was that you weren't told how many terms you had in your series. You had to figure that out yourself. So a little hint, you will definitely have a question like that on the quiz. So make sure you know how to do that. And let's look at another example, finding the initial term in the common ratio. So if you're told that you want to find the first 7 terms, but you're only given 2 different terms, so kind of similar to what we saw before, you're given the 5th term, which is 5, and you're given the 8th term, which is negative 40. How can I use this to figure out what the sum of the first 7 terms is? So first you have to figure, I'm going to stick with what we had done before, which is essentially just subbing in these values into your equation. So I know that t at 8 divided by t at 5 would give me not the common ratio itself, but it would give me almost the common ratio, right? And again, there's different ways of listing this off. You could actually list it off like this. You could say, here, let me write this out. You can almost number this off and say, all right, I know t at 5 is 5. I know t at 8 is negative 40. And you can think to yourself, okay, well, how many times do I have to multiply by the common ratio so that I can get to t at 8? Well, I know I have to multiply 1 time to get to t at 6, another time to get to t at 7, and one more time to get to t at 8. So I'm multiplying by the common ratio 3 times. And so another way of writing that is 3 to the power, sorry, r to the power of 3. The common ratio multiplied by to the power of 3 there. And again, I can find this by simply taking, by finding out what t at 8 is in the formula, in the general formula, ar to the power of 8 minus 1. And I divide by the t 5 term, so ar to the power of 5 minus 1. Again, I notice that a cancels out, and then I end up with r to. Either way, regardless of how you want to reason through this, I think most of you can figure out that they are basically, to go from the 5th term to the 8th term, I have to multiply by the common ratio. I have to multiply the common ratio by itself 3 times. So I'm taking the common ratio r to the power of 3. Now, I also know that if I take my 8th term and I divide by the 5th term, I end up getting negative 40 divided by 5, which is negative 8. So what I know so far is, and again, I'm going to piece this together. I know that r to the power of 3 is, this is when you use your mathematical skills with powers, right? If I know that some number raised to the power of 3 is negative 8, then you work backwards and say, okay, well, what could that number be? Well, keep in mind, because the power is negative, then you know that the base would have to be negative because it's an odd exponent there, right? So we know that you can verify negative 2 to the power of 3 is definitely negative 8. So that means that my 2, right? So if it was positive 2, that means that r to the power of 3 would be positive 8, but it's actually a negative 8. So once you know what the common ratio is, you could find out what the initial value is. And again, we talked about this. You could find the initial value by using, again, you could kind of reason through this by simply knowing that the 5th term is 5. So if you want to find the initial term, you would simply have to divide by negative 2 until you get to the first term. So you could divide by negative 2, keep dividing by negative 2, keep dividing by negative 2 until you get to the first term. So it is possible to do that. But I wouldn't necessarily recommend that. And it's negative 2, by the way. I forgot the negative 2 there. I definitely would not recommend that. I think that might take a little bit longer, especially because you're not that close to the first term. And there's definitely room for error. So a different way to do this is that you could use T8, you could use the general form, the general term and sub in 8, or you could use the general term sub in 5. So what I'm going to do is I'm going to do it for T at 8 here. I'm going to replace the n value in the general term. Let me just erase this here. So we know the general term is t at n, a times r to the power of n minus 1. And what I'm going to do is I'm going to replace the n here with 8. And again, I already know what the common ratio is. So really all I'm missing is the a. The a is the only thing missing. And I know in this case, it's 8 minus 1. And this is going to be equal to, we were already told, is equal to negative 40. So that means that negative 40 is equal to a times negative 2 to the power of 8 minus 1, which is 7. So my next step here is just to figure out what negative 2 to the power of 7 is. So -2 to the power of 7, grab a calculator if you're not sure, and it's better to just verify. This gives you -128. So A is multiplied by -128 to give you -40. And of course, the last step here, just divide by -105/16. So I know what my A value is. And again, I personally prefer to use the equation instead of working backwards on your own. But again, it's your choice, right? You could have taken the fifth term of 5 and just keep dividing by -2 until you get to the first term, right? That would have worked as well. But remember, the first term is T1, right? It's not T0. So now that I know what my A value is, my first term, so 5/16, I know my common ratio is -2, and I know my N value is 7, because that's what it asked me for, the sum of the first 7 terms. I have an R value of -2 to the power of 7 with the sign, so make sure you include the sign there. So we take -2 to the power of 7, we know it's going to be -128, and -128 minus 1 is -129. Then we simply multiply -129 by 5/16. Again, this is just working with fractions. So if you're having a hard time with this, we'll do it on the side. So we take 5/16 times -129 over 1 divided by -3. So 5 times, so a positive times a negative is a negative. So we have 129 times 5. That's -645. We divide this by 16. And then, of course, this whole entire fraction gets divided by -3, positive. And again, the equivalent of dividing by -3 is to multiply by 1/3. And then we have 16 times 3, which is 48. And I don't think we can simplify any further, so we just leave it as is. And again, just a little caution, sometimes people really tend to focus on memorizing the formulas. Don't memorize the formulas, right? Really just try to. And a lot of these questions, they get easier as you practice. It's a lot of things in math, right? So the more you practice with this, the more you're comfortable you're going to get with this. So, and eventually you might not even necessarily force yourself to memorize the formulas, but you'll start to indirectly learn them, okay? And again, you have access to the formula. I tend to not have the sequences and series formulas memorized as much, but over time you will start to memorize them the more you use them. And again, there's the homework, so you can get started with it. Don't worry about doing all the questions, as I mentioned already. Just do as many as you can. And again, it's a lot of questions on there, but I hope that this is good